Ladies and gentlemen, what's up? Welcome to Section 1, Chapter 7. Here we go. Essential question. What is the relationship between rational exponents and radicals? There, by the way, is two words right here that you've already seen. Exponents and radicals. But what in the world is this when we put rational in front of exponents? That's what we're going to talk about. Here we go. Bam. Is it possible to have a fractional exponent? Meaning, can an exponent be a fraction? Now, before I even get into this, you all know you can have x to the second power. That's a piece of cake. You can have x to the fourth power. There's nothing wrong with that. You can have x to the 41st. You can have x to the 413th power. All of those are fine. You can have 3 x to the 4. You can have all that. It's great. But the question is, oh wait, let me back up. Sorry. You could actually do this too. Just remember, you can have x to a negative power. Nothing wrong with that. The question, however, up here is saying, can we have fractional exponents? So does that mean, can I have something like x to the 1/2 power? Or can I have something like x to the 1/4 power? What in the world? Is it possible for me to have something like x to the 4/5 power? What? And that's what it means by a fractional exponent. And my friends, the answer is yes. You certainly can. I'm going to show you exactly what this means and how it all works. And we're going to use these a ton, my friends, in Chapter 7. We're setting the stage for what's about to happen. Now, into your notes, you need to make sure this is written down. This right here. What is rational exponent notation? Well, here's the scoop. Anytime you have something raised to 1 over n power, technically, I mean, this is the general one, but anytime you have a fractional exponent, that's called rational exponent notation. So something like a to the 2/3 power, wonderful, that's rational exponent notation. So anytime you have a fractional exponent, rational exponent notation. You know this from before. Radical notation is when you have a square root, a root symbol, over something. Now this little n out here, we're going to talk about what that is. But that's your radical notation. And what we're going to discuss, and hopefully learn by the time that this video is over, is what it means for us to take radical notation and rational notation and go one way or the other. So if something's given to you in radical notation, how can I rewrite it in rational exponent notation? Or right, vice versa. If something's written like this with a fractional exponent, how can I take it and write it back to over here? Well, I'm going to show you how that comes about by doing some simple examples. Watch. You know this symbol is a square root symbol. Now, before I move on, I do want to show you this. We know that's the square root symbol, but what you don't know, or maybe you do, is that technically there really is supposed to be a 2 right there in that little V of the square root symbol, of the root symbol. Shouldn't say square root anymore. It's the root symbol. And that 2 is not written there. If it looks like this, it's just understood that the 2 is supposed to be there. It's very similar, guys, to when you don't write a coefficient in front of a variable if it's just 1. So if you have 1x, you don't write 1x, you just kind of write x. Or if you have x and it's x to the first power, you don't write x to the first power. It's just understood that there is actually a 1 exponent there and a 1 coefficient. Likewise, it's understood that if there's no 2 in front of there or in the v, it's really understood to be a square root. So let me put that there just so you understand what I'm doing. You don't need to now from here on out, but I'm just saying square root. So square root of 16 is a simple example. You know the square root of 16 is actually a 4. So I'm going to show you, if you kind of see how this looks, the n here in this example is 2. So if I put that 2 in over here, I'm going to have 1 over 2. So it's a 1/2 exponent. Weird. The base, a, is 16. So how am I writing it? I'm writing this goofy thing, the square root of 16, as 16 to the 1/2 power. I'm going to show you, using a calculator, that 16 to the 1/2 power is the same as what you got over here as the square root of 16. Check this out. Okay, so I'm going to put 16 in here. I have to use this little doohickey to raise it to a power. You see that little caret? It means it's raised to the power. In parentheses, I'm going to put 1 divided by 2 because that is my exponent right here. I'll end the parenthesis, and that's not the answer. I have to hit equals. Bam! Notice the answer is 4. It's the same as what it is over here. So what I just showed you is these two expressions, 16 to the 1/2 and square root of 16, is exactly the same. Interesting. Let me back this up. I'll do another one. Let's change up square root. Let's go with something like this. Let's go the cube root. So you're going to now see a 3 in there. So if you see a 3, it means cubed root. So let's go a simple example. Let's go cube root of 8. So if I'm asking you for the cube root of 8, it means what number times itself 3 times would give you 8? That would be a 2. Because 2 times 2 times 2 gives you that right there. So the cube root of 8 is just a 2. Well, watch this. Let me pull up my calculator again. For some reason it disappeared. Don't know why. So I'm going to show you that this expression, cube root of 8, is the same thing as 8 as my base, fractional exponent of 1 over this 3, which is the n right here. So I'm going to show you it's the same as 8 to the 1/3 power. Here we go. 8 raised to the 1 divided by 3 power equals. Oh, look at that. It's 2. So there's 2 simple examples of how it works. Now I'm going to show you, let me scroll this thing down. I'm going to show you how you can do this in a very weird example. But if you treat, let me give you another one, an example. Here we go. So we'll go like a to the, I don't know, we'll go 2/3 power. Is that possible? You betcha. So here's how you're going to treat this. Let me actually pull this over here so it kind of covers up our tree. But you should do this. Draw an A with a tree. Because my analogy is this. This analogy will make complete sense to you if you follow it. I'm serious. This is a great analogy. I'm not patting myself on the back, but it is really good. If you treat this fractional exponent in rational exponent notation, if you treat that as a tree where this is your fraction bar, 2 goes right here as the trunk of the tree, and 3 goes right here as the root. If I'm going to take this expression and I want to translate it into radical notation, where there's a root and there's something in here, well, a is going to be the same because the base is going to be the same. That's wonderful. How does it translate? Well, ladies and gentlemen, here's how it works. If you will, in a tree, the leaves and the twigs and the limbs are not the powerful part of the tree. The powerful part of any tree happens to be the tree trunk. So the thing that is above the fraction bar, that is your power. Power, that's the powerful part of the tree. The powerful part, that's the power. You'll see what that means here shortly. And then, going with my analogy, underneath the ground, which is the actual fraction bar, these are where all the roots are. Oh, did I just say that word? I did. Those are where all the roots of the tree are. So the thing under the fraction bar is the root. So if I'm going to take this and translate it, it would be into my radical expression, radical notation over here. It would be the cubed root. Why cubed root and not square root? Because that's the root. That's the root of the tree. Cube root of the base, which is a, all of that raised to a power of 2. That is weird. But let me show you how it works when we translate it. By the way, it works the same if you were given something like this. Let me erase. And let me give you another example. Let me put this back over here. Okay, so let's go the other way. Let's say we had something like this. I don't know. 5th root of x, all of this raised to the 2nd power. Something like that. Watch this. If I'm going to translate this into rational exponent notation, the base is going to be the same, but I need some type of a fraction over here. I need something on top, I need something on the bottom. Oh, check this out. What goes on top? Well, the powerful part of the tree is what goes, the power. Oh, the power goes on top, 2. 2 goes on top, and the actual stuff down here, the root is what goes underneath. Oh, the root. Oh, like that. Ladies and gentlemen, I'm telling you, if you remember this analogy, it's going to make tremendous sense. This up here, the 2, that is really ugly. Yuck. Let me erase that. There we go. So the 2, the power goes on top, the root, the 5 goes on the bottom. Let's do some quick examples so you see how this really works. Okay, so what if we take this one and we translate it into, as it says up here, rewrite the expression using rational exponent notation. So I'm writing something where it is a and then a fraction on top. Well, here we go. Base is 5, so 5 is my base. Wonderful. The trunk of the tree is the powerful part of the tree. 2 goes on top. This is my root. It goes underneath, right there. 5 to the 2/3 power. Wonderful. This one, it's 11's my base. The power goes on top, the 5. And the root, what's the root? Oh, there's no number there. Remember, it's understood that there's a 2 there, so 2 goes right here. This one, the base is 7. The actual power, oh, I don't have a power. Yes, you do. Remember, it's the same thing as a 1 understood to be there. So the 1 goes here, and the root 3 goes right here. I love this. This is so cool. Last one. My base underneath the radical symbol is -10. So that guy right there, notice what I'm doing, putting in parentheses. I'm grouping it together. The root, what goes underneath, is 3, and the power is 8. I think you're getting it, but man, these are awesome. Check it out. Keep going. What if, now I'm going back the other way. So now let's rewrite the expression using radical notation. So I'm looking for something like this. The root and that guy right there. Well, here we go. The base is 9, so 9 goes in the root symbol. Now I just got to figure out what goes in here in the V. Oh, that's the root. It's the bottom of the actual fraction. 3 goes right there. Where's the 4 go? It's the power. So the power goes right there. There's your answer. That's it. 43 is my base. My root symbol, what goes in the V? The root. 5. And 1. I don't need to put it. That's it. Okay? -14. Wonderful. That is my base. I'll put that in the old root symbol. And 7 is the bottom number. That's my root. It's the bottom one. And then it's all being raised to the 3rd power. Awesome. Last 2 examples. Now what you're going to be doing without a calculator, notice without using a calculator, evaluate the expression. So we have to put this together and actually do some calculation. But no calculator. Ha ha! It's too easy to put this in your calculator. That's why we're making you not do it. And yes, your quiz, by the way, when you take it, you won't be able to use a calculator. So you better practice. Or we'll master them in class. Don't worry. Well, how do I rewrite this? Well, first of all, let's rewrite this into radical notation. There's my base. So 8 goes in the radical. Ba-ba-ba-bam. What goes in the V? Well, let's figure out what kind of a root it is. Oh, 3 is my bottom number. So it is the cubed root of 8. And then I'm going to raise that to the power of 4. So how do I do this without a calculator? Well, I first of all do what's in parentheses. So I need to do this first. What's the cube root of 8? So what number times itself 3 times gives us 8? That's a 2. So this whole thing in the parentheses is a 2. And then what remains? Oh, I got to take 2 to the 4th power. So 2 times 2 times 2 times 2 in my head, or just write it down, gives you an answer of 16. And there you go. That's how you do it. That's your answer. Simple as that. But it all translates, well, it all starts by translating this thing, using my goofy little tree analogy, properly. So let's do 64 to the 2/3. 64 is my base. Root symbol. 3 is the, ooh, nice, another one of these. So it's a cube root, and then I'm going to raise that to the 2nd power. Well, what number times itself 3 times gives me 64? 4. Good job. So 4 is the cube root of 64, and now I got to raise that all to the 2nd power. Whoa, this is weird. I get the same answer. That's no coincidence, but that's just a coincidence, by the way. They all don't come out to be 16. So there you go. So there's your 2 answers. All right, ladies and gentlemen, I'm excited to master these questions with you all in class. It's going to be fun. I hope you took notes on all this stuff. If you didn't, go back and write that all down. All the examples. I'll see you in class. Later. Peace.